Welcome to the TimCo Retail Manager course. This course focuses on real-world application development. In this video, we're going to be posting our sales data back to the API from our WPF application. The end result should be that we save our sale into the database. This is going to be a fun one. Now, if you're a Patreon supporter at the $5 per month level or higher, make sure you head over to get the latest source code. Also, make sure you're getting your emails from me through Patreon. I may be sending out a couple of bonus PDFs to you in the near future. Now, either way, make sure you're subscribed to this channel so you can be following along. This actual course also has a playlist, and that's in order, just in case you missed something or want to go back to something. So you might want to check that out and maybe even subscribe to it. Now, as you think of suggestions, please leave them down in the comments. I want to hear your thoughts on this course. I went through last time and cleaned out a lot of that suggestion list and took care of the bugs we found and the things where I messed up and the places where we could do things a little better. And we got that list down at least smaller now. But I want to keep adding to it as you see things. Because I'm not perfect. I'm just one guy and I miss things all the time, especially when I'm trying to talk and type and think at the same time. And so if you see something, definitely tell me in the comments below, and I will try to incorporate it in a future video. Okay? So let's get started. Here is the project I have open, the TimCo Retail Manager project. Let's go to our Team Explorer and go to our sync and do a fetch just to make sure we have the latest code, and we do. So the idea here is we have this sales view, which looks like this, and we're putting items into the cart, we're adding quantities to them and all that good stuff, and it's doing the subtotal, tax, and total. And in fact, let's go ahead and kick this off just so that we see it actually working, to make sure that we haven't broken anything. But then as long as it works, let's pull this over here, and it's tim@imtimcorey.com. And it's my password, my super secret password. And it does log in. And if we add items to the cart, the subtotal, tax, total, all updates, the quantity updates, we can add a second one. And I can add something else as well. And it updates like so. So it's all working as intended. But now we want to have the ability to check out. Right now this button's grayed out. We haven't enabled this. We also haven't enabled the remove from cart yet. We need to do that at some point, and maybe we should do that real quick just to have it done. I do want to get it off my plate, but we also want this checkout button to be enabled once we have something in the cart. And then when we check out, what's going to happen, I'll close this out, is it's going to go through our API, which does not have an endpoint yet. So in our product controller, we just have a get, but we need to have some sort of post where it actually posts our shopping cart, where we say, okay, here's the stuff we bought. Here's the product we bought. And then we have in our TRM data, which is our database, we have the sale table, which is where we have the cashier who was operating the cash register at the time. To make the sale, we have a sale date, which is just the date and time of right now. And then we have a subtotal, tax, and total. That's all the stuff we got from the main part of the sale. But then we also have sale detail, which is where we link back to that sale and say, okay, here's the product that was purchased. Here's the quantity that was purchased. Here's how much it was purchased for. And here's how much tax was applied to this particular purchase. So we can have multiple of these detail records going against one sale record. So if you bought, a candy bar and a bottle of water and a sandwich, those would be 3 different sales detail entries, and you'd have one sale entry saying you bought those 3 things. Okay, so that's what we're looking to do today. Is we're looking to have this process going from our sales view all the way back through to the database. Okay? So let's this may take a while, so I'm not going to tackle a remove from cart right now. I'm tempted to because I want to get it off my plate. But it's one of those things where it's a tiny thing, and so it's not going to take too much time, but this may be a long one, so I don't want to get there right now. Maybe if we have time at the end, we'll get to it. Okay, so let's look at what we need to do. We have this cart, which if we look, the cart is, and let's move this over a little bit, the cart is called, what is it called? Cart. Okay, that's simple enough. So in our sales view model, which that is down here, we should have a cart right here, which is a binding list of cart item model. So we have this cart. What we want to do is say we're purchasing all of this stuff and then assign a couple of more pieces of data to it. And a couple of extra pieces of data are, well, let's look. We have the sale. We have the cashier ID, but that comes through whoever's logged in. So you don't need to pass that through explicitly. The sale date, that's whenever we're making the sale itself. The subtotal, tax, and total. This is a question that we have to answer. And that question is, who is in charge of determining subtotal, tax, and total? Now we're showing the subtotal, tax, and total right here. And we're doing these calculations. However, is that something we can trust? And that's a really tricky question. Sometimes people love to trust their user interfaces because they say, well, I control it. And yes, you do today. But here's the deal. We've got an API as our person in the middle. Okay, that's the person between our database and our front ends. And right now we have just one front end and it's WPF. And yes, we do control the code for this. And so we can trust the subtotal, tax, and total from this WPF application because we wrote the code for it. However, that API doesn't have to use this WPF front end. It could use a different front end, let's say a web front end. Now, if JavaScript tells us that, okay, we're buying 18 fluffy towels and the total is $1, do you want to trust that? Well, no, of course you don't. So we have to have this balance of do we trust it or don't we trust it? And we have to have also a balance of if we recalculate it, do we get a different number? Because if we do, that's not good. If we tell the user your total is $100 and then we say they paid $102 or we tell them to pay $102, that's fraud. Either way, it's either we're lying to our books and therefore we have a tax problem, or and also accounting program problem of missing $2, or we are lying to the customer and we say they owe $100 and then saying later, oh, it's actually $102. That's kind of a bait and switch thing. So we got to be very careful to make the right decisions here. It's not just as simple as saying this is the right answer. I think in a full-on application, what I would do is, first of all, the API would be the trust layer. That'd be the last place I trust to do any type of calculation. So I would not pass in a subtotal, tax, and total. However, in a larger application, and this is not a larger application, in a larger application, what I might do is have the user post back to the sale table the cart information and calculate, okay, here's a subtotal, tax, and total, and then return that information to the front end. And I'd mark that sale as pending. And then the front end would pop a screen up that says, hey, here's your subtotal, tax, and total. If there's a discrepancy, the user sees it at that point. So is the cashier, and they can either look at it, we can address it in the system, or they can figure out why there's a discrepancy. But at least they see it before they give us their credit card or pay in cash. And then we know for sure that we're asking for the correct amount. So that double back and forth. But in our system, I think what we're going to do is because this is a minimum viable product, it's a small application we're trying to improve over time. What we're going to do is we're going to trust that the calculation we did in the front end is the same calculation we're going to do in the API, which it's going to be, but that is a trust, that is an assumption. So that will be something you have to be careful to pay attention to going forward, especially in our testing. But we're going to leave it at 1. When they say check out, we're going to assume they've paid that amount and that that amount is the amount that we then calculate in the API layer. That way we're protecting ourselves in the API and not allowing them to tell us a wrong amount. But at the same time, we're not going and doing that double check. Okay? All that to say, this stuff can be complicated. So with that being said, if we look at our sale table, we don't need to pass in any of this information. Not the cashier ID, not the date, not the subtotal, tax, or total. Not to the API. We'll have to do something in the API at least, but until the API, we don't have to do anything. Now, the sales detail page, we have the sale ID, which we won't have yet, but once we do the insert over here, we'll have that for this. So we'll have a sale ID generated for us, and then we'll have product ID, which we have in the this view model, this cart item model. If we have F12 on this, we see we have the product, which the product gives us the product ID. So we do have that. The quantity, well, we have that quantity. If we go back, let's try this again. Since I went forward one, and I try to go back, but the problem with back is it goes to the last tab you were on, not back as far as what you did on F12 last. So let's F12 this again. Okay, so there's a quantity. We have our product, and we have our quantity. So we have the product ID. The product ID, we have a quantity. Purchase price, which is in the product, so the retail price. And then we also ask for the tax amount, which is also money. And that we have, it is taxable, and we have the amount we tax by. And where is that? Well, let's find out. So if we go to our sale view model and we look at, let's look at we're looking for the tax information. So subtotal will give us, and then here we go, calculate tax. So config helper dot get tax rate. iConfig help, oops. Control F12 takes me to the implementation. The tax rate comes from, the tax rate comes from our configuration. So if we open up the app.config, we'll see that the tax rate right here is 8.75. We're not pulling that from the database, which does make things a little more tricky because we have to have this synchronized with our API. Now we are saying that there's one tax rate. There's not a per region tax rate, which can get a whole lot trickier, especially since we have to calculate which region they're in. We're not going to do that. We're going to have one tax rate. So we're going to have to put this value also in the API layer. Is it ideal? Probably not. Is this a case where we put something in the database? Probably a refactor, yes. It's not something I'm going to do now because it's not quick. And this does work. And that's one of those things you have to balance when you're doing a minimum viable product is it the ideal way of going or is it the quick way of going? And there is a balance between the two. You don't want to write horrible code that you're going to regret as soon as you write it. But on the other hand, you don't want to spend so much time writing perfect code that you don't get something out the door. So I wrote a product recently that I'll be releasing the next couple of days. You probably want to notice it's a product. but I'll be using it in some of the things that I do. And I had to hit that balance because I know all the stuff I could do, and I had some really cool stuff I want to do, and I've got a list. But the minimum viable product is one thing, and I just got that one thing out the door. So I had a balance between the get it out the door and make it perfect. So in this case, I think what we'll do is we're going to have something very, very similar over in the API side to calculate tax rate. We'll put it on a list for later to come back and put this in the API and expose it in the API and then call it here to get it working. So we'll put that as a to-do. In fact, let's actually put it right here. To-do, move this from config to the API. So what we'll do is we'll keep the same method, which is why we have it here like this. It's just that instead of doing this, we look at the configuration manager and convert it to a decimal and then make sure it's valid. Instead of doing all that, we'll just call the API, get the value, and return it. So we haven't wasted any steps except these right here, which we can just copy and paste, and that's 5 lines of code. No big deal. Okay, so let's keep moving. So we have this tax rate here. We'll have to pull that in the API. Okay, and in fact, for now, let's just do that. So we have the API's library. We have internals. We have data access. We have our models. We don't have dependency injection yet for the API. It's another thing high on my priority list to get done. But again, minimum viable product says that we should get something working before we make things prettier. So let's copy this. I'm not a huge fan of copying one library to another spot, but I think in this case, it makes the most sense temporarily. All right, so I'm gonna put it right in the root. So I'll add a new item, a class. We'll call it config helper, same name. We'll paste this in. We will not have an interface. We don't have dependency injection yet. And we're going to change this anyways. We need to bring in the using system.configuration to read in that tax rate. Same basic principle though. We're going to read from the web.config instead of the app.config. So we'll read from here instead of our app.config. Let's close all but this and look for our app.config, which is right here. So we have our app settings, and one of them is tax rate. So do we have app settings over here? We have to, right? I don't see it. Okay. So that was right off the root. Oh, there it is. It's hiding on me. There we go. Same spot, same value. So that should be good. So now we'll have the tax rate to pull from at least. We'll just need to either instantiate that, or here's what we can do. We can make this static and just pull from it. No instantiation necessary. So just get tax rate, and it's going to return the decimal. So what that means now is for our sales detail, we have the tax amount, we have the purchase price. So purchase price times the tax amount plus 1. So purchase price plus the purchase price times tax amount is our final total. So we can calculate those two things. We have our quantity, we have our product ID, we'll get our sales ID. Therefore, all we need to do, so all of that discovery to come back over to our UI, to our sales view model, where we have our cart right here. We have a list of cart item model. That's all we need to send over to the API, is this cart item model. Now we're gonna break it down even further. We're not gonna send everything. We're not gonna just send display text. We're not gonna send all of product model. So product model has the name, the description, the retail price, which do we send that or not? I don't want to trust the front end, so we probably should not send it. We should send the ID and then look the information up. Quantity in stock and is taxable. Again, none of these we'll want to trust. We'll just trust the ID. So we'll send the ID and we'll send the quantity for each of these things. And that's it. So we'll have two values we send in. So what we're going to do is create a model to send the data over. Now we can create this. Right now I've created some models in the library. We can keep them there because this is not a UI specific model necessarily. It can be eventually, but for now we'll call this sale model. Make it public. And it's actually going to have just one thing in it. It's going to be a list. And that list will be of type. And we're going to create a new one. We'll create this sale detail model. And make it public. And now I can say prop. And this is going to be the product ID and prop and the quantity. And that should be all we need to send. Everything else, let's just verify, everything else should be gotten somewhere else. So sale ID and quantity. Purchase price we'll get from a lookup. Tax we'll get from a lookup and a calculation. So that's all we need to send over is those two values. So now we'll take these details and now we'll send over a list of sale detail model called sale details. We can copy that. And now when we do a purchase, we'll send over just a sale model. That's it. And that sale model will have a list of the details in it. That's all we need to do. It's not quite as simple as just do it. So let's go over to our sale view model. And we have a cart. We have a subtotal. We have tax. We have a can add to cart. Then down here we have can checkout. Okay. So right now can checkout is set to false. We need to do something to change this to say that it's set to true. And then down here in the checkout, we need to create a sale model and post to the API. That's what we need to do here. So let's start with a can check out. Then the can check out should be if the list is populated. So let's look at what that list is. It should be cart. So if the cart model, if cart dot count is greater than 0. So if the items in the cart, the number of items in the cart is greater than 0, that should be all we need, right? Because if we remove something from the cart, now the list goes back to 0 if it had one thing in it. So I think that's all we really need to do, and then say output equals true. We'll verify that's all we need to do, but I think that's pretty simple. And in fact, let's do it. Let's make sure this works. All right. So logging in. There we go. And notice checkout is gray, but if I add something to the cart, it's still gray. Excellent. Do you know why that is? because we never triggered to say, look for can, or update the can check out, notify a property change. So whenever we remove something from the cart or add something to the cart, we need to, whoops, still running. We need to update the can check out. And that's for an add to the cart. Let's try it again. This is the way you test things. Because you forget something or you miss something little and you have a problem. Now, somebody asked the other day, isn't authentication something you add last because it's such a pain to use? And I answered, and the answer is, notice that works now. The answer is no, you want to add it first because you want to make sure that authentication is working the way you expect it. And you don't want to have any holes where you don't notice that you didn't put authentication. But there are ways you can make this easier. And one of the ways is I can actually hard code my login name and password into those boxes. So go to the login view model, and I have the username and password. What I can do is I can say, here's the starting value for username, and don't look, just kidding. There's the starting value for password. And now if I start this up, it should be those boxes have a value in them already, and I just hit login. Okay, so I can skip the step of having to type those in every single time. Now, you may have just freaked out because I put a password in code, which I will check in as source code, and you shouldn't have to worry. And here's why. Because this should never go to production. You should, as soon as you go to production, and maybe even as soon as you check in, you should take these out. However, the other thing is, even if this did go to production, this should not work in production. If it does, you have a problem. And the problem isn't with your code. The problem is with your database. You should not have a username of this right here with this password. You should not have that in production. Now, there's also some things you can do where we could do some debug flags in here. So if you're in debug mode, then we set that. It's a little more complicated than we need to get to, but that is a possibility as well. But I think this works just fine for testing, but as soon as you're ready to put it in production, you take those out. Okay, so that's just a little side trip based off a comment I received. So now that we have the can checkout working, we need to get down to the checkout. So if I hit this button, the first step we need to do is create a sales model. So sales or sale model, and just call it sale equals new sale model. And we should also, while I'm thinking about it, the sale model should initialize this list. I don't want to leave initialization up to the user. And by user, I mean the guy typing or the person typing this checkout code. So now we have that. We can say, let's do a for each. For each, we can do item in cart. So for each item in the cart, what we'll do is we'll do sale details add. There we go. New sale detail model, and we'll do product ID equals item dot product dot ID, and the quantity equals item dot quantity in cart. With those two things, now at the end of this for each, we'll have converted our cart from the cart item model list over to a sale model with an internal list of sale detail model, which has just the product ID and the quantity. Now, the last step is to post this to the API. However, we neither have a place to call that, nor do we have a place in the API itself. If we look at we have a library here, our desktop UI library, and we have the API helper, which right now has an API client. And from that, we can make some calls, and we have our product endpoint. So for example, for the get all, we have API helper under .api client .get async, and that's the call right here. Well, we need to create one for the sale endpoint, which we don't have yet. Now we could create one on this side and pretend, but I think what I'll do is I'll create that endpoint in our controller up here in the TRM Data Manager, which is our API. And then from there, I will come back over here to the endpoints down here. Instead of product endpoint, we'll have the sale endpoint, and we'll set that up to actually post a sale. Okay, so a lot of moving parts now, as you can see. So we have really 5 different pieces. We have a database, we have the API, we have the API's DLL or class library, we have the WPF friend and the WPF friends class library. So a lot of different moving parts to keep track of. Does it get difficult to do so? Yes. Is it made more difficult by the fact that you have just one person on a team? Absolutely. If I was working on a team, I would probably already have an endpoint from the API person. The API person would have created the endpoint that I need, or I would have said this is the endpoint I need, and then from there I would have built my side of it on the WPF side. So it makes it more difficult when you're doing all the different steps, all the different layers yourself as you go. But it is what it is. So let's create a new controller. We'll create an API controller empty. So if we create an MVC controller, that's something totally different. That's a web controller. We want the API controller. And we'll call this the sale controller. I think that's appropriate because we've got up here we have a sale and sale detail. We're going to call it a sale because it's one sale that has details in it. Now, you could start this from scratch, but here's what I do. I have a working one right here. Also known as the authorize right here. We're going to make sure we use that. But I'll just copy this and paste it in here. Are we going to do a get? No. But that gives you something to work with. So the authorize, and I'll even comment it out just so I have, again, an example of what it might look like. So I'm going to have a public, I'm going to start off with void. We may actually return something here, but for now I'm going to be simple about it and just say public void, and we'll say post. Let's just call it post. And it's going to take in a model. What model? We don't have one yet. Now, some have argued that I should share a DLL between my front end and my back end so I can have the same models. And I vigorously argue against that. And the reason why is a couple of reasons. First of all, long experience. And second of all, because they're 2 different things. So let's start with the 2 different things. If I want to decorate my model on my front end for display, I can do that. But as soon as I do that, it's no longer valid or no longer has the valid stuff for the API. And the opposite is true. If I want to decorate it for the API, it no longer is valid for the front end unless I bring in those libraries to handle that type of authorization or whatever I'm doing in that model. So that's one thing, is I want to be able to have that separation. And 2, when it comes to my long experience of doing this, what I have seen over and over again is you create this mess of we depend on this DLL, we can't change any of the models, so therefore we have 18 different versions of product because we depend on this product for this, but we have to change it for that, and now the WPF product is a little different, and so we changed that model for just WPF, and so it's called WPF, but now we also use it for the web front end as well. But then we had to change something, so now we have what used to be WPF, now just web. It gets messy. So even though it sounds like a good idea, the concepts behind the solid principles and dry, those aren't necessarily applying because of the fact that these are not the same thing. Dry does not apply if two things are not the same. And by same, I mean purpose, not just code. So keep that in mind. Because if two things, let's just say, this is a good example. We talk about object-oriented programming. If you say, well, a car and a boat both have motors, therefore they can inherit from the same class. No, usually not. Because, yes, they both have motors, but they're different. They're different. They're different types of motors. And as soon as you start trying to apply any more stuff to that, you find out, oops, they're different, but we have a same common base class. Now we're up a creek. So just be very careful that I strongly encourage you separate out your models from your front end and your back end because they are different. Your user interface models are different than your back end models. Now, if you have one project or one solution, like technically do here, you might be able to share them for some things at first, but again, you're running down a road that you're going to cause problems with eventually, or encounter problems with eventually. So I do have one solution here, but that's more because it's an ease of use rather than a true one solution. Okay, so that's a way long tangent, sorry, but I just want to point that out to make sure I covered it. Okay, so we have let's actually make a front end model for this. So TRM Data Manager, we're going to create a model for this is a sale model. We're going to call it the same. And we're going to have a sale detail model. So our sale detail model has these two properties. And our sale model has this property, which is a list of sale detail model. And we're going to call it sale details, which I believe is what we called it in the other place. Let's just make sure. Sale details, yes. Now in the other place, I initialized that list. Here, I am not going to initialize this list because I do want to know if it's null. This is one of those places where that change does take effect. I want to know if you're posting in a sale model. So you post in that sale model and it comes through as null. That's a problem, and I want to make sure I know that so I can check for null. So there is a little bit of a difference here. I don't want to initialize that because I'm just going to be wasting that initialization that's not necessary, because if I'm not getting the data, I shouldn't start with data. I mean, it just kind of makes sense. I shouldn't start with data that I had to overwrite. All right, so what we're going to do is, this is how I approach this. I'm going to put a console write line with nothing in it and put a breakpoint here. Just something to say, yes, it came through, and I can inspect this element. Because oftentimes I find it doesn't work the first time through, and instead of setting up all this code that then I try and debug why is that code not working, I find out it's not the code itself, it's the fact that I'm not posting a model or not posting a complete model, that I go, oh, that's the problem. So I'm just going to put just this right here, just enough to get a post method. So it's going to get the sale, so sale slash post, actually it's slash sale. So we will go over to our library here. We have our product endpoint, which I'm going to copy. You know what? I'm going to copy all of this code. again, to have that example. By the way, we can get rid of this example now. Let's do that. So I'm going to create a new class in the API library for my WPF application. I'm going to call this the sale endpoint. I'm going to get public. And I'm going to paste this code in here. I do have to change my constructor to the correct constructor. And I'm not going to use this, but I want to have it as an example. Okay, so what does this give us? Well, it brings in this API helper using dependency injection, which is what allows us to make calls to our various endpoints. So we're going to create a public async, if I can spell it right, async task, just task, and we're going to call this post sale, and we'll take in a model of type, and it's the sale model. Sale model, control dot, add our using statement for that, and we'll say sale. So now we have our command. We can start with this statement right here, our using statement. We do a using statement because then we can capture and make sure that we dispose of this call in the correct manner. And instead of get async, it's going to be post as JSON async. And it's going to be /API/sale. And we have to pass in a T value. So some kind of generic, which is going to be sale. So we're going to get back, we're going to post to sale. We're going to post that value that we're going to send through, which is our sale model. And then we're going to do this code right here. So if response.isSuccess status code, then we're good. Otherwise, we should throw an exception. And so let's do that. Let's do our else. And we have down here we said new exception and reason phrase. I'll do the same thing. It's good to follow the same patterns. And so here we're not really doing anything. So we can do a to-do log successful call. Probably not. You know what? Let's just not leave it as to do, but leave it as a comment with a question mark. Do you want to do that or not? But if it's success, cool. We're not returning anything. We could just call return here, but it's going to exit out at the end. We have this throw here if it is not successful. So we do capture and let people know, hey, that didn't work. So we can see that there's a problem. So we have a sale endpoint. Let's do our control dot here to extract an interface. Okay, and now we have an iSale endpoint in our bootstrapper, which is not the place where we're going to keep all this, but at the end of the day, we'll have to improve how this is done. We'll move this out in its own class. But what we can do is we can do dot per request, and it's an iSale endpoint, sale endpoint, like so. So what we just did was we added that to dependency injection. So now whenever I ask for an iSale endpoint, I will get back a new instance of sale endpoint. We're going to take that interface and we're going to go over to our sales view model. And up at the top, where we bring in iProduct endpoint and iConfiguration helper, we're also going to bring in iSale endpoint and call it sale endpoint. And then I'll copy this. I'll paste it right there actually, and put an underscore in front of sale endpoint. And so now I can say sale endpoint equals sale endpoint, like so. And now way back down the bottom, remember we created this this sale right here. So we can say we need to call that sale endpoint dot post sale and pass in our sale. The problem is that this is an async and we're not actually awaiting it. So we do want to do that, which means we need to change this to async task, and we need to await that. So now we're going to await the post of the sale. If we have a problem, it's going to throw the exception and bubble that out to the user, which right now is not being caught. But I think that is good enough for now. Now we did put in our API in our sale controller. We have that breakpoint that's on right now. So in theory, if we have wired everything up correctly, and if I didn't forget a step somewhere, it should be that I can add to my, waiting for the actual API to load. There it goes. It should be that I can just say post and it hits that breakpoint. So let's just add a couple of things here and check out. And we hit the breakpoint. Let's go to our local window and look at the sale, which we have. Sale detail has 3 items in it. That's good. And the bottom one is product ID of 4, quantity of 1, product ID of 1, and product ID 2. So we have 3 items in the cart. That's correct. And it's come through to the API. So we now have our API capturing a sale. The next step is for our API to do something with that data. So let's look at our data library to see how we do other things with data. So we have our data access for product data, where we have this get products, and it's going to get information from a database. So we're going to copy that basic concept, and we're going to have it for the sale data. So let's just create a new class right away called sale data. And we'll make this public. And just like before, use the patterns. Now I'm copying and pasting here mainly because I'm on one screen. Now I do have more screens than that. Actually I have one big screen I split into 4, but because I'm only recording one screen, I mean, you don't want to see all 4 screens at once, that'd be too much. So because I'm doing that, I'm copying and pasting. If you have 2 screens, what I would do is I would just drag this. Notice how it pops out. And now it's on its own. You can move it to a different screen. And doing so would allow me to put it on a different screen and look at it without having to actually copy and paste. So I can also split, but again, my font is so big that splitting makes it difficult to see both, and it gets a little confusing. Okay, so what I'm going to do here is I'm going to have a public, again, let's just say void for now. If you don't know what data type to return, just put void. And then when you figure it out, you can change it. So public void save sale. And we're going to pass in our sale data. We're going to call it sale. So now we have this, this method right here which takes in the sale data. Now this is again a question mark because I call this data access. And that's what it's doing. It's doing data access. Notice really clean little method that does one thing. It just saves, or in this case, just loads data from a database. In this case, should be just saving data to the database. However, I do have the question of my business logic, because the business logic is going to have to deal with how are we going to do, calculate the total and the subtotal and the tax, and how are we going to build these models correctly so we can then store them in the database. There's a lot of work to do, and typically I would not do this in data access. It's much more of a business logic style code, or even just a separate bit of code that does one thing. It calculates tax. Okay. And then no one just does calculate subtotal. And so you have 5, 6, 8, 10 different methods to handle the overall save a sale. In our case, what I'm going to do is I'm going to put this code in this one method because, again, minimum viable product. I am going to mark it, though, as a break this apart. This is not solid. Make it better. Okay, so I'm going to note, in fact, I'm going to do that right now. Make this solid / dry / better. Okay, that's my yelling at myself that, yes, I know, I'm acknowledging the fact that this is broken. So what steps do I need to do now that I'm kind of freed up to just write code? But again, sometimes the best thing you can do is just write code and then refactor it, because working code is so much better than awesome code that doesn't work yet. Okay, that is important. There's a balance, but it's important. Okay, so what do I have to do here? Well, what I need to do is I need to first create, or let's just say, start filling in the models we will save to the database. What I mean by that is right now we have a product ID and a quantity, and that's it per product. I'm going to put those into bigger models that are not full yet. Models that are going to match the actual sale data table. And then I'm going to go through and fill in the information. And then at the end, I'm going to, let's actually write this down since I'm talking about it. Fill in the available information. From there, create the sale model. Then save the sale model. Put an L at the end of that. After that, get the ID from the sale model. After that, I'm going to update or finish filling in the sale detail models. Let's call it sale detail models. And then I need to save the sale detail models. Okay, so that's my steps I need to take. And yes, there's a lot of steps there. And the reason why is because, again, we didn't trust the front end. The front end could have given us all this information. We could have just saved it in a couple different steps. But because we didn't trust the front end, we have to verify this information. So let's start with, let's close everything but this. I do that a lot because otherwise my tabs just fill up and I'm not sure where I am, so I end up using this over here on the right anyway. I'm going to collapse down my UI and my UI library because I don't need those right now. I'm also going to collapse down my API. I don't need that right now. This is just the data library and my SQL. So let's start with a sale detail, which the sale detail has, we're going to save the sale ID, the product ID, the quantity, the purchase price, and the tax. Those are the 5 things we're going to save. So we're going to create a model that is the sale detail model. And we're call a sale detail DB model, just to be clear on this. And in this, and we're gonna do a split screen for this one because it's pretty necessary. We're gonna match what we have up here in our table. So int sale ID, int product ID, int quantity, and then decimal purchase price. And finally, we have decimal tax. Okay, so it matches our table. And that's the reason we're going to match our table is because of the fact that we're going to use this as our model to insert into our store procedure, which will match the names up there. Therefore, we want to match names down here. So, all right, so we have our model now, and we want to, we're passing in the sale data. Whoops, and that's not right. That's our data access. That ain't right. What we need is actually this model, which is the sale model, and we have our sale detail model. What I'm going to do is I'm actually going to drop these down into the library since I don't see a need to have them in the front end. There's no front end specific code here. So I'm going to then delete these two. Yeah, so I'll permanently delete them. And that should break something. We'll see. If we do a build, didn't break anything. Interesting. The reason why is it looks like maybe, oh no, that's why. Okay, so the reason why it did not break something is because we didn't have the right, notice this namespace here, trm data manager.library.models, whereas this is trm data manager.models. So that's not right. So we can control dot here to change to the correct namespace. And we'll need to change the other one as well, which that is a sale model. Nope, sale detail model. Control dot. This is a new thing to rename the namespace. When it does, it actually adjusts the namespaces everywhere. So notice that it used to have an extra using statement here. It's gone now because it's referring to the sale detail model, which has changed where it's located. So even though I changed those namespaces, it did not add an error. So Visual Studio is getting smarter and smarter. Okay, so now over here, we're not passing in sale data. We're passing in the sale model. We'll do control dot, add a using statement here. That's better. So now I'll convert the sale model over to a sale detail DB model and also a new class for sale DB model. So we have two models here, one for the sale, one for the sale detail. With that, let's pull up our sale table. And again, we will put this down below. And we need a few pieces of data. We need the string cashier ID, and that's the ID of the logged in user. We either need a date time from the API or we need to allow the default value in the database. I'm going to do the API. So date time is the sale date. And for this, I'm going to do equals date time dot UTC now. I'm going to have a default value for that. And then I'm going to have 3 decimal types, subtotal, tax, and total. So I'm going to match this table exactly. I'll create the values for this later because of the fact that I won't have the total tax and the total or the subtotal until after I calculate all those values from the details. All right, so let's start by filling in the sale detail model. So I'm going to create a list of sale detail DB model, sale details. Let's call it details. And then for each sale details, I'm going to create a details.add new sale detail model, and I'm going to have the product ID. The product ID is going to equal item.product ID, and the quantity equals item.quantity. And that's all the values I have to start off with. Now let's look at what the other values are just real quick. We have purchase price, sale ID, and tax. Those are the three things that we're going to have to figure out. So now we need to fill in the available information. Now, we could do that in this loop, and I'm tempted to. I think I will. I'm going to rewrite this loop. Here's why. Because once I go through the sale details and loop through and add these items, I now have to loop through my details to add more information to them. So it makes sense, instead of looping twice, to do the same loop, and instead of adding it directly, I'm going to say var detail equals new sales model, and then at the end of it, I'm going to say details.add detail. And the difference here is that in between, I can do more work to populate the additional pieces of information. Specifically, if we look at this, we have the purchase price, and then we have the tax. So purchase price is going to be the original purchase price per item times the quantity, and the tax is going to be the purchase price plus the purchase price times the tax. No, just the purchase price times the tax. That's the tax itself, and then the total would be the purchase price plus the purchase price times the tax. So, gets a little confusing? Yes, it does. Let's start by, we need to get the information about this product. So how do we do that? Well, we are already in the API. We don't have to make an API endpoint for this. We can just make a call to our database. So we can come down here to our product data. In product data, we have get products. We can say public product model get product by ID int product ID. And then we're just going to copy these three lines right here, paste them in. And in this case, we're going to pass in a type. So we're going to say ID equals product ID. So we're going to pass in one variable, if you want to call that a parameter. But instead of SP product get all, it's going to be get by ID. And now that's going to return a list, actually a list. We only want one. Therefore, what we'll do is say at the end of this, dot first or default. And what that does is it returns either null if it didn't find anything, or it returns the first item, which is the only item in the list. So we need to create this store procedure. So add new store procedure. The store procedure name is get by ID. And we're going to pass in at ID is an int. And what we're going to do is say begin, end, and in between. Let's do the set no count on, and then we'll do the same select we do for get all. So we just copy that and paste it in here. But instead of an order by, we don't need an order by. We'll just say where ID equals at ID. So now we're going to limit this to only be one item. So now that store procedure is written, and don't forget we have to publish this. So in fact, I'm going to publish that right now just because if I don't, I will forget. That should create the new database for us, or the update to the database for us with the new values. Done. And now that store procedure is there. We'll grab the first one. So we have the get product by ID. Now I can come over to our sales data, and in here we can call that method. Now in our product data we just do SQL.load data. Okay, so we have this over here, but we need to call it from over here. So we actually need to create an instance that, again, no dependency injection, not there yet. So we'll create a product data products equals new. I shudder a little bit when I do this, but new product data. And now, let's not instantiate it here. That's silly. We'll put it up here. That way we only instantiate it once, not once per for each. So now we can say var product info equals products dot get by product ID, which is item dot product ID. So we'll get that item. Now, if any of these return null, we should throw an exception. Because it's not in the database, then that was not a valid sale. So if product info equals null, then throw new, let's say new exception, and say, let's do our $sign syntax. The product ID of item.product ID could not be found in the database. Big bad problem. Okay, so if you can't find it for whatever reason, throw an exception, let the user know there's a problem we did not complete. Now that we have this, we can say detail dot, and we have the purchase price. So that would be the subtotal essentially. So the purchase price equals product info dot retail price times, and we have our quantity, detail dot quantity. Now I could have said item dot quantity. That would have worked as well. It's up to you which one you want to use. I think actually from now on I should probably use detail. Let's just do that so that from now on we're no longer using item once we create our detail. Does it matter? Probably not. So now you have a purchase price, and now you need to figure out if it's taxable, then by how much. So the first thing we should do before we go any further is we should open up our front end and look at the sale view model and look at how we do tax, which is right about here, which is actually right about here. Okay, so the calculate tax is what we do if it's taxable, then the retail price times the quantity in cart, we already have that, times the tax rate. That's the tax. Okay, so essentially just the price we already have, the purchase price, times the tax. Well, where does the tax come from? It comes from the config helper.get tax rate, which we have over here. So we can say, let's grab that tax rate once instead of multiple times. Var tax rate equals config helper.get tax rate. So we have an if statement. If the product info dot is taxable, I'll leave it like that. If it's taxable, then detail dot tax, and that's the amount of tax we paid, equals the detail dot purchase price, which is the total of the retail price times the quantity. So the purchase price, we're going to multiply that by the tax rate. We're going to store that in the tax for the detail. And that should be all we need. We have the tax. We don't have a sale ID yet. We don't have that yet. The quantity, we have that. The purchase price, we have that. The product ID, we've got that. And that's it. So we're all set now with populating the detail object. And now we have these sales details listed in the details object. Okay, so details is populated now. So we've done the fill in the available information. We need to create a sale model. So the sale DB model, and this is the sale to save. I'm not in love with that name. Let's do this. I'm going to put a semicolon there. Instead of calling this sale, let's call this the sale info. So I'll control dot there and rename it. So that's the info that comes from the call into the API. Now what we'll do is we'll call this the actual sale. So we have sale and detail. So we'll do a new sale DB model. And then in here, we need to save the sale model once we have populated it. So let's go through and figure out what we need to do to populate it. Let's actually just do our curly braces here. Like so. I'll put my semicolon at the end first. That always bugs me they don't do that. And now we have cashier ID, sale date. We already have sale date taken care of. Subtotal. Well, subtotal is all of the purchase amounts, the purchase price, added together. And then the tax is all the tax added together because it's only 0, and that's fine. And the total will be the subtotal plus tax. So let's do that. Subtotal equals details dot sum x dot purchase price. So we're going to add all purchase prices together. And then, oops, can't put a semicolon there. It's a comma. The tax is going to be details dot sum of x dot tax. And then the total is going to be, well, you know what? Nope, total we're going to do later because of the fact that we're doing these two inside the curly braces. Therefore, we'll say sale.total equals details.sum. Nope, not even that complicated. Equals sale.subtotal plus sale.tax. There we go. So with that being done, we have those three, but we still need to get the ID of whoever's logged in. Well, that's actually passed in because we don't know that in this method. So we're going to pass that in. So string user ID. And so we'll say that the cashier ID equals user ID. We probably shouldn't call it something different. So let's call it cashier ID and control dot to rename that. So now we have, that should be all of the, whoops. Yeah, we have sale date and total. Those are taken care of. So the sale date is that default value of UTC or datetime.utc now. So it's going to be the universal time code for now. And that's what's going to default to every time. We don't need to change that ever. The only time we need to change that, and the reason why I have it in the API being set instead of the database as a default, is just in case we do want to have the concept of not processing these sales right away. Let's say we put a sale into a queue and then we process at the end of the night or something like that. We would need to then have a date and time in the queue as part of that record that we then use as the date of the date and time of the sale. So just so you know, that's why I did it that way. All right, so now we have this, we have the sale record. We can go ahead and save this sale record. So to do this, we need to create a call to the database, which really simple, looks kind of like this. Actually, I'll cut this out from here and I'll move it down below where I can see it. Something like that. And let's create this up at the top because I'm going to create it right here. It depends where you want to put it. We already put it once in here, didn't we? Or no, we didn't. Okay. I'm just thinking out loud. So I want to put it as low as possible because that way it's open for as little as possible. But at the same time, I don't want to confuse people as to where it is. So I think that's fine right there. What we'll need to do now is we will need to say SQL.SaveData of type T. And that type T is SaleDB model. And the stored procedure name to save this, we don't have one yet, so dbo.spSale. Let's look at our naming convention here. Yep, sale, sounds good. spSale underscore insert. That looks good. And then we need to pass in our SaleDB model, which is sale, and the connection string, which is TRM data. That's actually the connection string name. It's the ID of the connection string, not the actual connection string. So that should save our sale model. Now, off the top of my head, I do not remember if it will pass this, it'll update this model with the ID, which this model currently does not have, which let's actually update this model to have it. Let's do a F12, and we'll do an ID here. I don't know that it will pass this back, but we're going to find out. Make that an output in our store procedure. If it doesn't work, we have a couple of options. One option is to use the dynamic parameters that Dapper gives us as a type and then capture those back at the end and read out that ID. Another option, and this is a simple one, especially if your database is not SQL, if it's something else where you might not be able to get this information back as easily, what you can do is you can just save it and then query for this exact same data. And as long as you don't have two sale entries with the exact same data, which you should not, then you should be good. Okay, so that's another possibility. But we're going to see first if we can get this ID out using this, using the properties of this instance, which basically says that since I'm passing just the address of the class, not the whole, not copying the data across, then it should be that this, when this class gets updated, if it's updated, then I'll see that value. So we're going to find out. So get the, for right now, we'll just say that the sale.id has been updated. If it's not, then I'll probably do the lookup. It'll probably be quickest to do the lookup instead and then populate the ID. Either way, what we'll do is we're going to assume we have it, and then we're going to finish filling in the sale detail model. So we're going to do a details dot for each. We could do a for each this way, or we could do a for each like so. For each, I'll just do this. It's simple. On the details, and we'll say that item dot sale ID equals sale dot ID. All right. So now that that's been updated, then we can save these to our details model, which is SQL dot save data. We don't need to pass in the type. I shouldn't have done it up here because it can infer the type. Because this type right here is of type T, therefore it knows what that type is. Notice when I say, it says T right here, but since it uses T as a parameter, it can infer that from the type being passed in, therefore we don't need to specify it. If we're not passing in a type T as a parameter, we have to specify it. Just a little trivia there. So, DBO dot SP sale, and it's sale detail underscore insert, and the parameter is well, it's going to be item, and yes, that's not available yet because we need to do that inside of our for each loop, which means that yes, we're going to call that insert statement once for every item in our details. Sometimes that makes people panic because of the idea that we're calling our SQL database too much, but the SQL database is used to this. This is what it's designed for. However, if you really feel like you're calling it too many times, and by that I mean thousands of times in a row right away, then you can create a table value parameter, and you can pass all those values in as one big table. Now to do that, if you watch my advanced Dapper video, that will show you how to do that. But we're not going to do that. There's no reason for it. It's not that many calls. This is actually more efficient than calling or creating a table value parameter to do this. All right. So with this, I'm going to save this. I'm actually going to put a breakpoint right here, because I want to find out if this sale does update the ID or not. And if it does not, I'm going to stop it. So we need to call the save sale from a sale data. And that's going to be called from our sale controller right here. We're going to say sale data, which is a usage statement. Data equals new sale data. Data dot save sale. We're going to pass in our sale model and also that cashier ID, which I don't have at the moment. How do we get that cashier ID? Well, that was, let's see if we, right here. That's the get the user ID. So I can come over here I can paste this in. What this is doing is it is reading off the identity of whoever's logged in. And we can use that to then be the ID of the cashier. They can't fake that. They can't pass in a different value because it's pulling off the authorization, not off of something they gave us directly. So that should wire that up. So now let's find out if, oops, I forgot something. You're probably yelling at me already. I created a couple of store procedures that I didn't actually create. Or just one, I think. SP sale. Do we have that? We do not. So I created two. SP sale insert. So add new store procedure SP sale underscore insert. And this is going to take in, let's, oops, I can't do that. I don't have multiple screens to put there, so I'll do it this way. And this is going to be a, oops, SB sale model. So I'm going to say at ID int, I believe it's called output, and then at cashier ID, and that's an nvarchar 128. And then I have a sale date, which is a date time 2. And then I have a subtotal, which is type decimal. And then I have, nope, it's type money. There we go. And then I have a tax, which is type money. And I have a total, which is type money. And I'm going to begin, end, set no count on. That just cleans up a little bit of the data that's returned. We don't return all the information we need. We don't return account information, which just saves a little bit of traffic across the wire. So with set no count on, then we're going to do an insert into DBO dot, and this is the sale table. And then from here, we need to say cashier ID, sale date, subtotal, tax, and total. And say values at, here's what I do. Copy this line right here, paste it in here, put the at symbol in front of all of it. And you're done. So there's an insert, and then we're going to select at ID equals at identity, like so. What that does is it grabs the last identity that has been created inside of this transaction. And since a store procedure is a transaction to itself, that's going to be this insert right here and no other. And therefore it grabs that identity and it puts it into our ID value. So now it's going to insert that, and now we should have that value, hopefully, if it passes it back correctly. So let's save that. And then we need to do one more, and that's for our sale detail insert. So add a store procedure, sale detail insert, and we're going to look for the sale detail DB model. Let's bring this out first. But then up here we'll do the sale detail DB model. And this is going to be at sale ID int, at product ID int, at quantity, which is an int, and then at purchase price, which is of type money, and then at tax, which is a type money. And now we'll do the same thing. We'll do our I wonder if the IntelliSense doesn't work because I do the begin. I'm not sure. Because IntelliSense should work, but it doesn't always. Insert into dbo.sale detail. It is sale detail. Make sure you get your singular versus plural. Sale detail, which it is sale ID, product ID, quantity, purchase price, and tax. And again, I'll copy that. Values, paste it in, and put my @ symbol in front of all of these. I don't need to capture the IDs coming back for this. Doesn't really matter. So that's done. Now I should publish this. Once we wait for this to publish, then we'll be able to run this application. We've got our breakpoint still in place at this for each. So in theory, this should all work. And I love theories because they never seem to work out the first 18 times. All right, so let's log in once the API is done loading, which is almost done. There we go. Log in. I'm going to purchase, let's purchase 2 skillets and a fluffy bath towel. And check out. We're already down here. We have done the insert. Let's go to locals and let's look at sale. And the sale ID is 0. So it did not pull that back, which is a bummer, but not entirely unexpected. I kind of feared that was the case. So what we'll do is we'll stop it right here. Yes, we'll have a sale in our table that is kind of dangling. We can clean that up later. I'm not going to spend time on this video since it's going quite a bit long. But let's go ahead and get the ID from the table. So let's create a new store procedure. And we'll call this SP sale underscore lookup. Yeah, lookup. That's good enough. And we're going to look it up by, well, let's look at what we have passed in here. Since this is not working, we'll leave it there just as it is. But we're going to look it up by cashier and sale date. I think that makes sense because one cashier is not going to create 2 purchases, especially not on the same date and time specifically. So that should be good enough. We don't have to look up the total as well or anything else. I'm going to take those 2 values and I'm going to paste them in here. And then what I'll do is do our begin, end, and the set no count on, and then select. And my select right now, I should return, we have our sale. Let's just return ID. So ID from dbo.sale where cashier ID equals at cashier ID and the sale date equals sale date. And this shouldn't be a problem because we're not letting SQL create the date, therefore it shouldn't be different. And that is a concern otherwise. But I think this should work. So we're going to do SP sale lookup. So we're going to go ahead and publish this just so we have it published over. And while that's publishing, I'll come down here to my, where is it? Sale data right here. So here, what I will do is I'm debating what I'm going to do. I could just, let's try this. Let's just do an int. Normally create a model for this, but it's just returning 1 value. Therefore, I think we could map it over to an int. We're going to find out. So what we'll say is SQL.load data of type int and dynamic. And our store procedure name is not that. Our store procedure name is, I actually closed it already, SP sale lookup. Let's copy that. And then we're going to pass in the parameters, which is a new anonymous parameters. We have two. We have our cashier ID, which equals our, where is it? We're going to call it sale.cashier ID. And we also have our, we didn't actually, sale date, that's what it called it. We didn't actually modify it over there, so I couldn't see it in the list. Sale date equals sale.sale date. Now this is saying there's no argument with the, because we forgot one last thing at the end, which is TRM data. That's our connection string name to use. And so then therefore, there should be a list of int, which is first or default. So we can say var, or let's do int, sale ID equals, that's quite long, it's going to go off the page. Notice these are gray here. And the reason why they're gray is because since this is named cashier ID and since this is named sale date and those match the names, we don't have to pass in a new name. It's kind of like aliasing it when we do. We don't have to alias something to itself. Therefore, we don't have to pass in those. We can just pass the values themselves because the name of the parameter is what will be used for the alias. Makes it a little smaller. So now we have a sale ID. We can, instead of saying sale.id, we can either pass it in here as sale ID. Yeah. No. Let's copy this and do that. There we go. So now we're updating directly that sale ID. Let's find out if this works. Okay, now we don't have to type this. We have to actually wait for the API to load for a little bit. So let's do 3 skillets this time and 2 fluffy bath towels. That's how I roll. Check it out. Now let's look at the sale.id, which says, if you can read that, the sale ID is 2. Therefore, yes, we've gotten that value. We've got that value back. So now it should be that I can just hit continue and it's done. Let's find out if it's actually done. So let's stop this and let's go to our SQL Server Object Explorer and let's look for our database, which is TRM data. Inside tables, let's look at the sale table first. Let's pin this. So we'll say view data. We have 2 records. The first record we never used because that's the one that we broke. And the second record is, notice the cashier IDs. Let's look at them. Notice they're matching because I logged in as the same person. And if we look at this, if we went over and looked at, let's just read the last, it starts with 603 and ends with AD. Let's go over to our EF data and look at our users and look at Tim Corey, and my ID should be ends with AD and starts with 603. So that it does know who I am and it's putting that as the cashier ID. So it does know that. We have a subtotal, we have the tax, we have a total, and now that does not look right. Not even close. We made a mistake. And I think we did it before, which is that tax rate, we're storing it as 8.75 when it really should be 0.0875. And there's been some debate on which way we should go on that. We'll address that in the future. But for right now, I'm going to have to change that so the total is correct because that's just hideously wrong. But let's look now at the details and make sure this is ID 2. So sales detail, the data, sale ID of 2 for both of them, product ID, quantity, purchase price, and of course that hideously high tax rate. I should work for government. Okay, so let's fix the tax issue because that's a major glaring issue we need to fix. So let's find where our taxes is right here. And let's do this. Let's close all but this. I'm gonna unpin this. Let's find out what we did in the other one, because we should do the same thing in both places. So let's look at I believe it's right in the view model. This is the data manager. So no, that's not it. Down here. Okay. Sale view model and down to the end, correct? We had calculate tax. Well, let's find out. Tax. Calculate tax. F12. Yep, calculate tax. All right. So, tax rate we divide by 100. That's the bug we had. And yes, storing it as the full value does cause that bug to show up. Now it's fixed here, but we should put that on our to-do list to think about. Maybe we should put that 0.0875 instead of 8.75. It reads a whole lot nicer in our config file, and people understand 8.75 as a tax rate versus 0.0875. But it does lead to some bugs like this. With that being said, I think now we should have a fully working system for saving data back to our database. Let's verify this information just a little bit. So what I'm going to do is log in. We're going to add a toaster oven, and let's add 2 home repair kits and a fluffy bath towel. So our subtotal, I'm going to write this down. I'm going to do it off screen, but $129.94, the subtotal, $7 even in tax. That's interesting. And $136.94 is our total. Okay, let's check out. And it appears nothing's happened, but it has. If you go to SQL Server Object Explorer and look at our sale table, we now have a third record here, which is $129.94. That's correct. Interestingly enough, we have a rounding error, so 6.9956, which actually would round up to 7. And then we have 136.9356, which again would round up to 136.94. So yes, what we showed the user is correct. This is the more specific, but we should probably round those. But the way we're storing in the database is a little bit different. Okay, so but those are correct numbers. So we verify that does work. And yes, the tax is less hideous now. All right, so we're going to stop right there. It's working. Now, we gave no feedback to the user. We left the stuff in the cart. We've got a lot of stuff to clean up here, but we actually have something working that we set out to do, which is we put something in the cart, and then we can save it all the way back through to the database. Let's go ahead and go to our changes, which there's a lot. All these changes. And normally I'd review them all, but quite frankly, I'm going to stage them all because I know that those are just the changes we did. And yes, they're all valid changes, or at least I hope they are. And this is going to be saving the cart to the database. All the changes necessary to save the shopping cart data to the DB. I'm going to commit that to staged. Again, normally if I was working on this myself, but with a team maybe, or so working personally but with a team, I would probably not make one big old commit with all that stuff in there. I'd have a feature branch, I'd do all this stuff, and then I'd merge it into one. But for this, I think that's good enough. So that's now saved out to GitHub. And again, if you're a Patreon supporter with a $5 per month level or higher, I will have that zip file over for you on Patreon. All right, so that is our video for today. Quite a bit longer than normal, but I wanted to get that all into one video so you can see start to finish. Yes, it does get a little complicated. I mean, there's a lot of stuff moving in different parts, and it does help me write it down or draw it out or have some visual for what's going on in different pieces. It also helps if you're not breaking off big chunks. And this was somewhat of a big chunk because I was doing both sides of the coin. I was doing the API side and I was doing the front end side. If I were you, if I were breaking this apart into pieces, I might do just the back end API work and then do just the front end the next time. I didn't want to do it in this video because I want to show that a whole flow through, and it's hard to leave it as a cliffhanger. So I wanted to get through that. Now, like I said, we have some cleanup stuff to do, but I think that once we get the cleanup stuff done, I want to create a couple of quick forms that allow us to modify some of the data in the database. And then I want to move on to a web-based solution. Because remember, the goal of this is not to just have a complete not a complete full application. This is an MVP, a minimum viable product to get something working. And then what we're going to do is build a web UI that has different pieces for, again, minimum viable product. And then we're going to convert these things over to .NET Core. So we're going to move towards .NET Core eventually. And I want to get there because this is an example of how to take an existing application, a real application, and move it over to .NET Core. So I want to get there pretty quickly. So I want to get through a couple more things with the WPF side, then I'll move over to ASP.NET MVC, and from there to .NET Core, and then even Xamarin. So we're going to go down that road. All right, thanks for watching so much. I appreciate it. If you have any suggestions or if you notice something that you want me to change or tweak, or maybe have a suggestion for where to go next, I'd love to hear it down in the comments. I appreciate you all. Thanks for watching. And as always, I am Tim Corey.